Hello, my little triglets. I'm so glad you're with me again. Today we're going to do section 3.9, the last section in the chapter, which means we're going to have a test soon. I'll tell you in class when that's going to be. All right, this first word I'm going to write down, don't let it scare you. Are you scared? Don't be scared, really. Trig proofs, I like trig proofs way better than geometry proofs. So I hope you join me in that attitude. All right, the first thing we're going to talk about with proofs is the no-nos. The no-nos are you may not multiply both sides by anything. Okay, don't multiply both sides by cosine. Don't multiply both sides by 2. Divide is another thing you cannot do. Do not divide or multiply both sides. You may not add or subtract to both sides. And you may not square or square root to both sides. Okay, those are bad. These are not algebra problems. They are proofs. And you have to prove that one side equals the other. So let's start out with an easy one. On a scale of 1 to 10, I'd say this is about a 1. So everybody should be able to do this. Now, I also want to remind you that page 168 is muy important. Okay, so you need to know everything on that page to be able to do proofs efficiently and to do them correctly. All right, so what we're going to do, we're going to draw a line down the equal sign, and then we're going to start on the side that looks a little more complicated because it's easier to get small than to get big. So we're going to change things that can be changed. Sine can't be changed really into anything useful. Secant, however, is 1 over the cosine. Now, if you put a 1 under the sine, then you have two fractions, and you just multiply straight across, and you end up with sine. And then 1 times cosine on the bottom is cosine. And then we all know and love that as our tangent. So that is a trig proof. You're just trying to make one side look like the other. All right, let's bump it up here a little bit. We're going to do another problem. This one is a 3 or a 4, I would say. So tangent plus cotangent equals cosecant plus, nope, not plus, cotangent equals cosecant times secant. So we're adding on the left, but multiplying on the right. So addition usually makes things a little more complicated in these problems, so I'm going to work on this side. Now tangent, we all know, is sine over cosine. Cotangent is cosine over sine. Okay, now we have two fractions. To add fractions, you need a common denominator. Our common denominator is just cosine sine. It's those two. So what I'm going to do is I'm going to multiply the left side by sine over sine, because that's really 1, and the right side is cosine over cosine, because that's really 1. So we're not changing the integrity of the problem. On the left, we have sine squared. On the right, we have cosine squared on the top. The bottom is just our common denominator, sine times cosine. All right, from here, sine squared plus cosine squared, we know one of our Pythagorean identities says that that's 1. So 1 over sine times cosine. And now I'm just going to split that up as 1 over sine times 1 over cosine. And that becomes cosecant times secant. So we just proved it. It's correct. They are equal to each other. So if you know page 168, these become fairly easy. Now let's move up a little bit again. This one is about a 5 or a 6 maybe. Cotangent over secant equal to cosecant minus sine. All right, I'm still going to work on the left side because there's not a whole lot to change on the right side. So on the left, I have cosine over sine for cotangent. And on the bottom, I have 1 over cosine. That's what secant is. Now I have two fractions. Have you heard of outer outer over inner inner? So the two outside pieces make cosine squared, and the two inside pieces make sine. That's how you simplify a fraction over a fraction. Or you can invert and multiply the 1 over cosine. Becomes cosine over 1, and multiply straight across. You get the same thing. Outer outer over inner inner is just more fun to say. Okay, so now simplifying a little bit more, notice I have a minus sign over here. There's no minus on the left side here, but remember our Pythagorean identity, sine squared plus cosine squared equals 1. Well, I have just cosine squared, so if I can isolate that by subtracting sine squared from both sides, I'll get cosine squared equals 1 minus sine squared. So I'm going to put this in place of this because that's what it equals. So this becomes 1 minus sine squared, and the bottom is just sine theta. All right, so now I'm going to do something I call heart surgery. When you're trying to break up fractions, we're going to draw something that looks kind of like a heart. So I'm breaking apart this fraction by using heart surgery. So the part on the left is just 1 over sine. The part on the right is sine squared over sine. Okay, and simplifying that further, 1 over sine is cosecant. Sine squared over sine reduces to just plain old sine. So that's what we needed it to be. So when you have a fraction like this, and make sure the heart is upright. You can't do it with an upside down heart. Okay, it has to be upright. All right, so now we're going to do a tougher one. Now this one, on a scale of 1 to 10, if you don't recognize what it is, it's like a million. It's impossible to do. So you really have to recognize it. And this next one is going to be called a conjugate problem. Conjugate, you have to recognize it. The first thing you have to recognize is that you have a plus or a minus in the denominator. Okay, the second thing is there are no squares. And the third thing is it has to have a fraction on one side. Really, all of these refer to one side of the proof. One, not on, one side of the proof. Okay, so let me write one down. I'm going to go to the new page. Here we go. Secant over 1 plus cosine equals cosecant squared times secant minus 1. Okay, so on the left I have a plus in the denominator. I have a fraction, secant over 1 plus cosine, and there's no squares over there. There are squares on the right, but it's got to happen all on one side, so I don't care about the right side right now. It's only the left side that concerns me to be a conjugate. All right, so what you do in a conjugate problem is you look at the denominator and you're going to multiply the top and bottom by the opposite sign, but same pieces of that denominator. So instead of 1 plus cosine, we do 1 minus cosine. All right, so let's see what happens here. I'm going to distribute the secant into there. So secant minus secant cosine. And then on the bottom, it becomes a FOIL problem. So I have 1, then minus cosine, then plus cosine, then minus cosine squared. All right, let's try to simplify here now. Secant, now do I want to change that to 1 over cosine? No, because I have secant over here. So don't change things if they're already on the right side. We want it to look like the right side, so let's keep things that look a little bit like it. So secant we're going to leave. Now, secant times cosine, they are reciprocals. If I have 1/3 times 3 over 1, the answer is 1. So these two reciprocals are also going to be 1. Now on the bottom here, the two cosines cancel, and I'm left with 1 minus cosine squared. All right, remember when we had sine squared plus cosine squared equals 1. Well, this time I want to make 1 minus cosine squared. So if I do minus cosine squared on both sides, I'm going to get sine squared equals 1 minus cosine squared. So this gets replaced in to the equation for this. So I have secant theta minus 1 over sine squared. Sine squared is a reciprocal of cosecant squared, so I could bring this up and turn it into the cosecant since it's the reciprocal. And lo and behold, we now have what we started with. So that's a tough one, especially if you don't realize that it's a conjugate. Okay, so you have to see those three things that make it a conjugate. All right, this next problem is not a proof, it's just a simplified problem. I have a square root of 4 minus 4 sine squared. Okay, you may not take out pieces unless it's multiplication. So what we're going to have to do here is factor a 4 out front. So each of these has a 4. I'm going to factor out front. I'm left with 1 minus sine squared. Now the 4 can come out because it's multiplication here. Okay, the 4 comes out as a 2. And then I have 1 minus sine squared. Now, 1 minus sine squared is cosine squared. We just showed that on the page before. If you're not sure how I did it, rewind and look. Cosine squared now can come out, and I have just 2 cosine. Now, we want to make sure that it stays positive. The absolute value bars get thrown in to make sure it's the positive answer for that. The negative wouldn't make much sense, especially cosine is an even function, coseven. So that's it for proofs. Don't let them scare you too much. In class, we are going to write down the strategies to get going if you get stuck on these. So in your notes, put a little column for strategies, and then when we're in class together, we'll talk about those. All right, the main thing is page 168. Okay, that is the Trig Bible. Learn it and love it because we need a lot of Trig love. TTFN.